ahead and get going. So this is AWS CDK Beyond the Introduction. My name is Jason Butts. I'm a solution architect and practice lead of the DMI. Thanks everyone for coming here today. On the slide are social media links and such. I'm not on Twitter. I like Mastodon better. So join the Fediverse. So this talk is going to be, it's inspired really by a lot of the things I've seen newer users to the CDK do and where they went wrong and what they needed to do to take and really go beyond that introductory initial use case and start taking it to the next level and a more advanced usage of the CDK. So even though this is beyond the introduction, I am going to give a really quick intro to the CDK. The CDK allows you to define your resources for the cloud using different programming languages instead of using YAML. Instead of a couple thousand line configuration file, you actually use code, you get if statements and everything. Those cloud resources are modeled as constructs that encapsulate one or more different resources into what are hopefully going to be reusable objects. It allows you to abstract away a lot of the complex configuration and streamline the definition of your resources. So first thing to do to go beyond the introduction is don't put everything in the constructor. The CDK is made up of different kinds of constructs, and you can use those to break down your application, your framework, into a collection of resources. I have seen 2,000 line long constructors. It was hard to maintain anything. And sometimes you can't avoid some of it. If you're working with API gateway and you have a lot of different Lambda functions and different endpoints, things are going to get a little long. But maybe that API gateway should be its own constructor. That way you're not having to see that every time you go in to do anything. Keeping on that theme of constructs, you want to make sure you're using L3 constructs. Within the CDK, L1 constructs are the low-level, almost identical to CloudFormation objects. The L2 constructs are going to be intent-based, and they are wrapping aspects of permissions of aspects of configuration, and put it into a single object. If you're used to working with Lambda, for example, that function construct that you're using over and over, that is an L2 construct. L3 constructs are meant to hold patterns, and defining your own patterns is a way that you're able to abstract away the configuration. You're able to more easily test what you've built, and you are keeps it all cleaner. It makes it a lot easier to maintain everything, and you don't have to write all of these patterns yourself. AWS Solution Constructs is a collection that has a lot of common patterns that are already pre-built that you can make use of. For example, a lot of times if you're working with CloudFront and S3, you're going to be connecting the two, you're pulling static resources out. They already have a construct for that. You're able, yes.
So you have this microphone. I want to make sure that's
okay.
These walls are glass, and I don't want, if it's too loud, just.
Gotcha.
Sorry.
All right. So like with S3 and CloudFront, you're going to be connecting the two. You're doing the same sorts of things over and over again. And with that solution construct, it's already been built, put together, wired together using well-architected principles. You're not having to do all of that security configuration. You're just providing an S3 bucket name, maybe some other aspects, and then it's wiring all the rest of it together in a single construct. With the CDK, you can have one app and multiple stacks all grouped together. Within the CDK, you're always defining that CDK app. If you're using TypeScript, it's that, and the generators, it's that file in the bin directory. That's where it is. That's where you're defining all of the different stacks that actually can be deployed out. You can have more than one stack in there. And sometimes that is a matter of maybe you need different deployment requirements. If you are dealing with CloudFront and certificates, you may need things in US East 2 or US East 1, where the rest of your app is maybe in US East 2 or US West 1. You can also use that to differentiate things out for your different deployment environments, your dev environment, your test environment, staging, prod. You can have a separate stack configuration there with the same stack construct, but with the different configuration values outlined. It can save you a little bit from some of the configuration nightmares you can get into. One pattern I've seen is people will define they'll call it like an environments file, and it's just a giant file that is all the different configuration values. What domain name do they need? Or do they need to be using? What is the service discovery name? What are the different APIs that they need to hit for the different environments? Instead of having that on a separate file, you can build that in, and within that, I don't even know within that file in that bin directory, you're able to define all of those separate stacks, and it makes it a little bit easier to work with. One of the other things you can do with multiple stacks is separate out your resources. If you've used the CDK, you've probably gone through the nightmare of, okay, I need to upgrade the version of CDK packages, or I need to upgrade my database. And you're checking and checking again to make sure that you don't accidentally delete that production database. That is a nightmare I've been through, and we managed not to. The better way to do it is to separate out your stateful and non-stateful resources. Put that stateful database in a separate stack, and you can apply termination protection to that stack, and you can make sure that that database cannot be stopped. It cannot be shut down, and it cannot be deleted. Let's see. So I mentioned the deployments example. Here is a streamlined and simplified example of that. In this case, everything's going to the same region, 2 different accounts. We have different host names that we're needing to use with this sample application. And we can customize those each for the different deployment environment we have. With the CDK CLI tool, you're able to specify the name of the stack that you want deployed. And as an extra tip, it supports wildcards. So if you end up where you have 3 production stacks, 3 staging stacks, you can deploy staging, put a wildcard there, and not have to go through and list out every single stack name. Another example that I've run into is my own website. After the, December 2021 AWS outage, I thought it'd be fun to make my website, my personal website, more redundant. And that means multi-region setup, making sure that it can automatically fail between S3 buckets. Everything's static, but I have 3 different regions that I'm working with. And so I was able to split things out within the same CDK application into those 3 separate stacks so that I can deploy the resources that have to be in US East 1 to US East 1. I can deploy my primary resources to US East 2, and I can deploy the failover to US West 2. One of the things I was also able to do there is develop a redundant CDN L3 construct for myself. That enabled me to take all of my CloudFront configuration, all of the security headers, all of everything you need to set up, within CloudFront with the redundant or with the failover distribution and put that in a single construct. That has made the rest of the files so much cleaner, so much easier to maintain, and so much easier to work with. With the CDK, you're also working with object-oriented concepts. So within this example, my base S3 bucket, the configuration for US East 2 and US East or US West 2 is identical. There's no difference in their base configuration. So I defined a CDK stack class that handles that. But then for my primary region, I need to set up replication. So I was able to actually extend that base stack that defines those S3 buckets. And my primary region is extending that base stack. And I'm able to layer on top of that the replication that I need. That way I can have everything get uploaded in one region and automatically move to a copy to another. So using multiple stacks and L3 constructs, you can build out your application with more complex configurations while still keeping it easy to modify, easy to maintain, and easy to work with. So automated testing is another piece to level up your CDK usage. I'm not saying test all of your CDK, all of your resources. If you're not careful, you're going to end up more or less having two copies of your code. You're going to have the test version and you're going to have your live version. And there's really not going to be much difference, or your test version is just going to look like CloudFormation scripts. That's not really where you're getting the benefit. But where you are getting the benefit is with those L3 constructs or with those complex configurations where you're standing up something like a shared infrastructure. You can unit test that specific construct, that specific stack, and make sure that that configuration has the values that you need. With Jest and TypeScript, you're also able to use snapshotting. Snapshotting is a wonderful feature of Jest, especially for front-end development, but you can also use that with the CDK. In instances where you're deploying a shared infrastructure that is going to be used by a variety of applications, any change there is high risk. And with the snapshotting with Jest, you're able to actually version control what that should look like in addition to your code. And you have to accept those changes every time you run your unit testing. When used responsibly, it is a good extra layer of safety. But if you start applying it everywhere, your developers are just going to skip any pre-commit checks, or they're just going to change the script where it's going to automatically accept all of the changes. Let's be honest, I've been there, I've done that. Takes too long to run the pre-commit checks. No, I'll run it myself when I need them. So let's see. For an example of good unit testing, let's say we have a custom CDK construct that for Lambda we're wanting to reduce our IAM role usage within AWS or within our AWS account. So we want to reuse this IAM role because maybe all of our Lambdas need the exact same permissions. By default, the CDK function construct is going to create a new IAM role every single time. And you can pass the same value in every single time, or you can build a construct that does it for you. And we can have it set up where if that role doesn't exist, it can define it. If it already exists, it'll just automatically start using that when we use our custom construct. So you can define a test, and in that test, maybe you define 2 Lambdas, and you make sure that the IAM role is only defined once. You define another test, again, define 2 Lambdas, and maybe you define a Lambda that should be using this reusable role and another one that shouldn't, and you confirm that. You don't need to go through and define Is my Lambda referencing the right handler? Does my function have the right name? If you're extending the function construct, you can take some of that as already given. So it's a matter of focusing down where you're actually putting your testing effort. And this is not somewhere where you're really going to want 100% code coverage. So CDK pipelines are another place where you can level up your AWS usage or your CDK usage. But they're not right for every use case. So if you are looking at them, make sure that you do a lot of investigation. If you're doing true continuous deployment, they're great. Take a look at them. If you're in an environment where there's a lot of manual touch points, maybe you need a lot of sign off from product owners or somebody else before you can deploy, maybe you don't want to look at them as much. You're able to, or I guess they have constructs for CDK pipelines for both AWS Code Pipeline as well as GitHub workflows. And that is experimental, but it works very well. They do a good job of making sure that the deployments are effective, and it reduces the number of things that you have to deploy and define yourself separately. You're able to define and maintain your pipeline right alongside the rest of your application. So like I said, if you have a lot of approvals or slow approvals or complicated environment management, use caution, look at something else. But if you have one of those quicker moving environments, take a look at CDK pipelines. Now, this last one is straight out of the best practices for the CDK. Whenever you're developing with the CDK, you want to avoid non-deterministic behavior. Basically, if you give your CDK resources the same input, you want to always get the same output. You want to avoid anything that is going to change that or outside of your control. So when you're running that synthesis, you don't want to be going out and getting resources out of your cloud and running lookup queries. You don't want to be querying your internal secrets management if you can help it. You want to minimize the outside impacts to your deployments. One piece of this is, for example, if you're using the VPC from lookup, that is a special static method that it does actually do that lookup of what is in your AWS account. But it takes that and it will cache that in the CDK context file. And what that CDK context file is, it builds out an account region specific pairing of resource information of what your account looks like at that given time. And as long as you have that file and you have that file committed, it will always go through and look up that, from that file first. So if you're looking at doing this in your environment, run that synthesis on your machine for each environment. That way you get everything cached. And that way you know that AWS isn't having to go and dynamically look up those values. One of the trade-offs with that is, if something in your environment does change, you have to do manual effort in order to ensure that that context file gets updated and starts using the right values. If you don't do that, it's not going to work. So if you have, maybe shared infrastructure and an infrastructure team that maybe feels like cowboys every once in a while, use with some caution. There are other ways you can get value, you can pull values into your stack. But if you do have that stability, or you are the one in control, it's going to help speed up those lookups, help speed up the your deployment, and it's going to help prevent those unexpected deployment failures. So as a quick review, don't put everything in the constructor. break it out, use constructs, and separate things into smaller pieces. Develop your own L3 constructs. Build your own patterns, reuse them within your application, and if you're reusing them within application after application, maybe create your own internal shared library. Within your CDK application, use multiple stacks. Break things down how you need, and you don't have to separate it out into all of these different repositories. When appropriate, unit test your resources. Make sure that you are deploying and defining what you think you are when it really matters. Look at the CDK pipelines if your environment supports it, and make sure to avoid non-deterministic behavior. That's all I have. This QR code will take you to a page on my website where all of these links are available. I believe they're also going to be sharing out the slides. Hopefully all the links work for that, for there, but that is all I have. Are there any questions? Yes.
What are your thoughts on naming things?
Naming things yourself versus CDK naming things. There are times where you should name things yourself, but most of the time, let CDK, let CloudFormation handle it. Your stack names for CloudFormation are always they have to be unique. And CloudFormation and the CDK will make sure that those resource names are unique within your account and your region, et cetera, as necessary. If it's something where you need this value elsewhere, for example, if you're deploying an IAM role or a permission boundary that needs to be used across your account, giving it a nice name is not such a bad idea. But you also have to be careful on the resources that you give names, because if they're not able to, or I guess it depends. Some operations, when you're deploying resources, will need to replace that resource. And if you're defining that name, it's not able to do that as effectively or at all, depending upon exactly what you're deploying. So most of the time, let CDK and CloudFormation name it. Does that help? Or does that kind of work? Do you agree? Do you disagree?
No, I agree.
Okay. Yours is testing. Fair enough. Any other questions? Comments, burning desires? Yes.
So in AWS,
All right. Trying to think how to summarize that question. So I guess talking a little bit more about the CDK and defining different environments and different, and how well it handles that. I showed that you can do that with having separate stacks defined with each different configuration value. You can also have a single stack in that file, and you pass in environment variables to work with some of those dynamic values. One of the clients I work with, they do that very extensively for about a quarter of their configuration. The rest of it's hard-coded, and it works very well. One of the key things, especially if you're looking to have a single stack defined and deploy it to multiple environments, is to be sure that that's one of those cases where you might want to consider actually naming the CloudFormation stack and using environment variables there to make sure you get different stack names. The client that I'm thinking of, they have the test and staging environments are the same AWS account, whereas production and development are separate. And so resource conflicts is something that we've always had to be very careful of. Does that kind of get to what you were going for? Okay. All right. Are there any other questions?